All right, let's take a look at the three power theorems for chords, secants, and tangents, and then let's jump into some problems with them. All right, so our first one over here, these are chords. Chords go from one endpoint on a circle to another endpoint on a circle. They do not necessarily pass through the center of the circle. And our rule for chords is as follows. One section of the chord times the second section of the chord will be equal to that same proportion for all the chords that intersect with each other in a circle. So to summarize, that says A times B equals C times D, and that is the power rule for chords. Okay, moving down here, these are called secants. So they're both originating from a point outside the circle, and then they pass through the circle. And so the rule for the secant is as follows. If you multiply the portion outside the circle times the entire distance from the outer point to the point on the circle, then that will be the same if you do the same proportion with this secant. So if we call that C and we call the whole thing D, then the rule here is that A times B equals C times D. Only this time it's not the individual pieces of it, it's part whole equals part whole. Now, if we move over here, you can see we've got one secant, but here we have a tangent. A tangent hits it in only one point versus a secant, which pierces through it. And the rule here, same concept, part times whole. But here we don't have a differentiation between part and whole, and therefore we multiply it times itself, or we square it. So that would be A times B equals C squared. Okay, so to quickly reiterate, in two intersecting chords, part times part equals part times part. In two secants originating from the same outside point, the part outside the circle times the entire secant equals the part outside the circle times the entire secant. And finally, over here with our secant tangent, same start, part times whole equals part times itself, or C squared. All right, let's put these to use in some problems. Stay tuned because this is going to show you some tricky things that teachers love to pop into tests, including how you hide quadratic problems in these. Here we go. All right, so here we have a rather wonky circle, and what are these called again? Yes, that's right, chords. So we know we're doing part times part equals part times part. So let's imagine the givens of this problem are as follows. Let's say we're told that this chord is divided into segments of 4 and 6. And then let's say we're given the information that chord AD equals 14. Okay, so the way we get to work is we want to define both of these parts in terms of the same variable. So I'm going to pick one of the parts and call it X, which means I can define my second part as 14 minus X. And that's key. You don't want to define it as X and Y because then you're going to have one equation, but two variables, right? We need the same number of equations as variables. So now we go ahead and we follow our instructions that part times part equals part times part. And so we're going to say that 6 times 4 equals X times 14 minus X. And now we're going to start to work our way through. So I went ahead and distributed this and did this multiplication. I want to get everything to one side because I can see I have the start of a quadratic equation here. Why do I want to get everything on one side? So that I have a quadratic I can factor. I'm going to use the X method. If you're not familiar with this, go check out this video, but here we go. I'm asking what multiplies to 24 but adds to 14. I like to make a factor list to help me out. So when I look down this factor list, that looks like it could make a 14. Okay, they both have to be negative. Those are my factors, which means I have two possibilities for X. And when I check them both out, if X is 2, then I have 2 and 12. And indeed, 2 times 12 equals 4 times 6. Or if X is 12, I have 12 and 2. And again, indeed, 12 times 2 equals 6 times 4. Next problem. Okay, so in this case, I've got secant, secant, and I've been given that this part is 3, this part is 5, AB is 15, and I need to find x. So I'm going to go ahead and start on this side where I have everything I need. So again, it's part times whole, so that would be 3 times 15 equals part 5 times whole 5 plus x. So I'll go ahead and do this math out, and I'll keep solving my equation, and I'll finish solving my equation, and it's as simple as that. Okay, last scenario. All right, so this time I have a tangent and I have a secant. So I know that part times whole equals tangent squared. And so again, I'll start to do this out, and then I'll move things over to one side, and then I'll do my x method, and I'll make my factor list, and I see 4 and 9 could get me that 5 I'm looking for. And I see that the 5 wants to be positive, so that means the larger factor wants to be positive, and my smaller factor wants to be negative. So now -4 and 9 is 5, -4 times 9 is -36. I have 2 factors, but only one possible solution. All right, there you go. Those are the power rules. Those are some ways that teachers love to use them on tests that make you also practice your quadratic work. So if you're rusty on that, go check out my factoring playlist or check out these videos on factoring quadratics. Take a look at my other video that deals with chords, tangents, and secants, but from the point of view of their arc measures and how they relate to inscribed angles and things like that. And as always, keep on mathing.